luunu. This is the research work we propose on annsim 2022. With this research, we are proposing blockchain MISP. MISP stands for Malware Information Sharing Platform. Model cards and federated learning enables cyber threat intelligence sharing platform. These are the authors of this work: Keranga Bandara, Ajin Shetty, Abdul Rahman, Navi Mukamala, and Subilla. First of all, I will give a brief introduction about me. I'm Merang Bandara, working as a senior research scientist at VMAS Virginia US. Involved with various research on blockchain, distributed systems, cybersecurity, machine learning, predictive machine learning, and recently we involved with 5G. Our main motivation of doing research is we always try to do research and apply this research into real world production grade applications. luunu is one such platform that we have developed based on our research work. This is me. I'm available on Twitter. If you want, we can contact via Twitter as well. Okay, let's look at some background information first. CTI or cyber threat information. CTI sharing involves process of collection, analysis, and sharing of cyber threat information among multiple organizations. CTI sharing may advertise the vulnerabilities that may be present in organizations' infrastructure. So that's a crucial thing. So the CTI, when share the CTI information, so it exposes some vulnerabilities exist in organization. So due to this reason, CTA is highly sensitive and has potential to harm an organization reputation if it leaks. So that's the main concern. Therefore, the privacy and anonymity of the participants in the CTA network are crucial. We could simply build some CTA sharing platform by using cloud-based infrastructure, but using external cloud storage to manage this kind of data can cause problems such as data integrity, data leaking, and privacy. For example, the cloud service providers manage physical access to data; they can easily access the data, so some data leaks may be happen. To address this concern, so with this research, we propose luunu, which is blockchain MISP model card and federated learning able CTI sharing platform. It supports traceability, anonymity, and data governance of the CTI sharing in scalable fashion. luunu equipped with self-sovereign identity enable mobile wallet to ensure the anonymity of the cyber threat information reporters. So we propose a mobile wallet application to report the cyber threat information. So it enables self-sovereign identity-based approach. So it stores CTI information on the MISP storage as a model card objects. So we all the CTI data we stored on the MISP, we encode CTI data into a model cards. Model cards are some objects that could be used to recognize the data provenance. I will show more information. The blockchain-based federated learning system analyzes the collected CTI data on different participants. So we propose some network so that we can deploy this network among multiple organizations on top of blockchain. So the machine learning platform that we have incorporated in here uh, can do learning tasks with the CTI data among different organizations. So in privacy safe manner, we use some federated learning based approach for that. Let's look at the architecture of the system. So we build this system as a layered system. There are 5 main layers: stakeholder layer, smart contract layer, blockchain storage layer, MISP storage layer, and data analytics layer. Stakeholder layer, so these are all the participants in the loan platform, basically reporters, service providers, and viewers. CTI reporters, CTI viewers, and service providers, the host of the platform. Smart contract layer, all the functionalities of the system in different types of smart contract. Basically, 4 main smart contract: identity contract, CTI contract, FML contract, and notification contract. Identity contract handle the identities of the reporters and viewers. So by using identity approach, CTI contracts handle the CTI reporting, viewing, and searching kind of data. FML contract handles the federated machine learning function related data. Notification contract handles PHP notification. Blockchain storage layer stores all the digital identities of the entities, stakeholders in the system, as well as data provenance information of the CTI. In my space storage layer, we encode CTI data into model card objects and stored on the MISP storage. Data analytics layer, so it's a federated learning service involved there. So it's capable to do the federated machine learning. It's capable to generate machine learning models by using federated learning approach among different organizations. So this is the data information. Now let's look at the functionalities. So there are three main functions in the system: identity registration, identity approval, identity report, and viewing the incidents. If we look at the identity registration, so first the incident reporters and incident viewers need to be registered on the luunu platform. They can do identity registration via luunu Biowallet application. On registration, the user needs to capture the identity information, personal information, image, organization information via the mobile wallet. Then captured information will be stored on a secure storage on the mobile application, and the proof of this information will be uploaded to blockchain as a self-serving identity proof. This is the place we incorporate self-serving identity. So this is the way it works. So there's a admin needs a condition verify incident reporters and incident viewers. Basically capture personal information, generate public-private key pair, create DID in the self-serving identity terms. It's called DID, decentralized identity. So we generate DID. It basically with the base 58 hash of the public key. Then we create DD, upload this DID proof into the blockchain ledger. So this is the how format of the DID proof: DID name, role, public key, status, and details. This is the DID proof we stored on the blockchain. So this is the mobile wallet application, how it's look like. So we get the personal information, we get the photo, on top of that we can get the signature and to the registration. All this personal information will be stored on the mobile wallet if we don't expose it to the cloud storage or any other party. In approved identity. Once DID proof registered in the blockchain, it need to be approved by the admin in the loan platform. Admin can approve the identity information via the admin web application, person admin web application. Uh, to approve identity, admin required users actual ID information which resides on the user mobile wallet. In here, when approving, admin will directly fetch that user ID information from user's mobile wallet by using peer-to-peer channel and verify them and approve. So that's the way it approves the data. So this is the way. So fish DID proof from the blockchain. So then you DID proof, and if required, it fetch actual ID from the reporter and viewer and approve that. Then report and view incidents. Then registered users in the loan platform can report cyber attack information by the mobile wallet. When reporting an incident, it takes incident data, incident category, description, current status, efficient percentage, and various information related to CTI data. The incident category defines the type. Basically, it could be DDoS attack, network, different types we have defined. In here, the main thing is that these reported uh, incidents are encoded as model card objects and stored on the MISP storage. These reported incidents can be viewed in the web and mobile application as a model card. So this is the way it works. So once the identity approval is done, so they can report cyber incidents. So report incidents can be viewed by the credential viewers. So this is the mobile wallet report incidents. So this is a category then report incidents. So this is a model card. So I mentioned previously all the uh, CTI information. So CTI records we encoded into model cards. So it could contain various details, model details. So attack information, attack matrix, different data can be encoded into the model cards. So CTI data encoded into model cards and saved in the MISP storage. Now let's look at the implementation. So we have implemented the live version of this loan platform. This is the architecture of the implemented system. So we build this system as a microservice-based architecture. Different services are there. So they handle different functionalities in MySP service, notifier, federated learning service, host service, and services are there. There's a blockchain ledger which stores the SSI proofs and data provenance information. Let's have a closer look of this system. So we build this platform with microservice architecture. Services are capable to deploy the Kubernetes-based environment. Peer-to-peer communication or microservice communication handled with the Kafka-based streaming by using reactive streaming approach. To implement the blockchain platform, we have used a blockchain called Rahasa. Rahasa is a blockchain system that we have built. It's another our researcher. Uh, Rahasak's main goal is to integrate blockchain with enterprise applications like big data, IoT, cloud application. So that's the blockchain system that we use to build the loan platform. So smart contracts of the Rahasa blockchain. Uh, we implement the functionalities of the loan by using Rahasa blockchain smart contract platform. So we build some novel smart contract on top of Rahasa. We call it Apple smart contract. It's a functional programming and actor-based concurrent transaction enabled smart contract platform. So all the functionalities of the loan implement with the Apple smart contracts. To peer-to-peer communication between mobile wallets, we use Firebase. TensorFlow Model Card Toolkit used to build the model card service. To build the federated learning functionalities, PyTorch and PyTorch PyZip libraries have been used. So that's the details about the implementation. Yeah, so that's it about Luno platform. If you have any questions, we can discuss them